All right, well, I'm going to go ahead and get started. Anybody else that comes in can come in late. I don't know if someone's having some, I got a text from one of the guys who's having login trouble. I know one of the other dudes is having the power problems. So I'll just assume the other 8 or 9 guys that signed up for this either forgot what time or couldn't make it for whatever reason. So I had about 12. I have 12 people that signed up for this. So instead we've got 3 in here. So, so maybe I should have not limited it, but whatever.
You got the ones who matter, I guess, right?
Yeah, it's the ones who matter. That's right. So, and if everything goes well, like I said, we'll record this. We're recording now. Get it up online so anybody who missed it might be able to come back and watch it again. So, diving right into it. The whole impetus of this class really is to just talk about some different ideas, some different varying ideas of getting away from vices. And we all know that, you go buy a machine, standard machine that we're going to use today, size-wise, is going to be a 40-20 table, 40 in X, 20 in Y. And you go and buy a machine like that, or you have a machine like that on your floor, and everywhere that I go, and I 500-600 different machine shops that I go into in my territory, more than that really, but just straight job shops anyway, the 500 or 600 that are just straight job shops. It always irritates me when I walk into these places and I see, nice machines, they're well kept in some cases anyway. And you go and you look at the table and there's one vise on it, or there's 2 vices on it. And so they've got a 40-20 table and they're using anywhere from 6 to 12 inches of it. And that's it. And it's like, why did they buy a 40-20 table to start with if that's all they're going to do? So a lot of thoughts gone into this this first run example here, but I want some feedback from you guys that are here with us today. This is meant to be kind of a back and forth thing. This is not going to be me just telling you, here's how you do it and go do it. And that's it. The feedback back and forth with people makes this what I'm going to be walking through with you today, what it is. And nothing is ever developed in a vacuum. So you always need back and forth. So anytime you guys have questions, just chime in. So, okay. So to start with, the example that we're going to look at today is this part right here. I'm assuming everybody can see that.
Yep.
It's just a brass part. It's a simple little part. It's not very big. It's almost square. I kind of actually forget what size this thing is. Well, let's see what is this thing in size? It's about 3/4 by 3/4 in size. So, and it's a little brass part. And the customer that was of mine that was running this on a brand new VMX 42. That's a little bit bigger than a 40-by-20 table. But he had 4 of these in Vice 1 for his first op, running just like what you see on the screen. You can see where we play it. Cutting it out. This is doing 4 parts anyway. I can zoom out. You can see the 4 parts. And we can turn on toolpath. I forgot toolpath turned on. Anyway. So he's doing 4 in op 1. Then he's putting them in another vise for op 2 and taking off that backside. There's just this little bit of backside left over here. So he's cutting all of those up individually on a saw. A stack of them, just loads and loads of them on a table in buckets. And then he's just putting them onto the machine and into the vices, clamping them down and going, right? So every time he opens the door, he's getting 4 complete parts. And that cycle time that he had that he gave me was 8 minutes and 42 seconds. That's really slow. That sounds really slow to me. I don't know about you guys, but that sounds really slow. 8 minutes and 42 seconds for 4 brass parts. Now, when I went and did this, and this is just a full disclosure thing here, when I went and did this and programmed this for the first 4, you can see my cycle time that I've got here. And I could not get it anywhere near as slow as him. So I got 3 minutes and 30 seconds for op 1. Granted, there's an op 2, but you're just facing off that excess. So that's probably only going to be, let's just be conservative here and say it's another 30 seconds and you got 4 minutes. So you're looking at a minute apart. Okay. So that's kind of what I came up with when I went back and talked to him about this. Could not figure out how he got 8 minutes and 42 seconds. But at any rate, we're going to start with the assumption that if I was running this part, we'd be looking at a 1 minute cycle time per part. He has 2,500 of them to run. Yeah. That's how many he ran like this.
Wow.
He was running the whole damn week. So first problem that he's got here, and what this whole fixture plate design concept does for you, is if you think about this, even from the standpoint of before you even get to the machine, what did he have to do for this material? He cut up 2,500 individual little brass blocks. Well, that's a pain in the ass.
Yeah, it is.
I mean, I see a lot of guys doing this. And I don't know, I think it's just a matter of that's the way they've seen it done. That's the way they do it. And they've got to go, right? And it's an automated saw, so let it go, right? But whether it's an automated saw or not, the handling of all of that is absolutely killing you. So even if we go back to that 4 minute cycle time, okay, it's not really 4 minutes. You've easily got a whole minute there of taking all 8 of those parts out, taking the 4 out that are complete, taking the 4 that have done op 1, putting them over into vice 2, loading in your blocks into vice 1. I mean, you're probably closer to 5.5 minutes, right? Does that make sense to everybody?
Yep, it does. Yep.
So that's the other part of this whole design theory that it eliminates all of that. It just, that kills you. And so, for instance, like with this part we've got right here, you can see where we've done the machining on these other 4 parts, but I'm going to my stock geometry here real quick and take X and make it, 10 inches long. I'm just going to cut a bar. Right? I'm just going to cut a bar. And when I put this on my fixture plate, this is what I'm going to wind up getting. Now, obviously, I need to do more than 4 if my bar is 10 inches long, but you get the idea, right? In op 1, I'm just taking a bar and putting it across the plate however long I wanted it to be. If it was going to be, if my fixture plate is 40 inches, because I've got a 40-20 table, and because of the way I laid out my grid, then maybe I'm going to cut these things into, an overall length here, just a bar that is, it's brass, so it's not heavy. That might be 40 inches long. I might make it 36 inches long. I might come out and say, okay, if I measure this, or if I think about this from the standpoint of what's my spacing got to be, because obviously I've got some crap here that I could have made the spacing a little bit better so it doesn't leave anything without the cutters obviously hitting anything else. But I'm going to have a solid bar here. So let's just say we cut it at 10 inches for making things quick and easy today. Well, we can fit easily, 1, 2, 3, probably 3 more in there, maybe 4 more in there, and get 8 in a bar, right? So now we're not handling. Our handling time isn't per part 2,500 times. It's divided that by 8 or by 10 or by 12 or however many you fit into that bar. Okay. Now, how that then fits onto a fixture plate, let's talk about that. That's kind of the next thing. And what kind of clamps we want to use for fixture plates. And we're even going to talk about what it looks like to buy a fixture plate. These are the guys that I go to. I'm sure, hopefully you can see my screen here as I refresh. Let me know if there's any lag or anything, guys. But Howard Precision Metals is kind of where I've sent everybody for fixture plates here recently. A 42 by 26 plate that's already ground and ready to go out of aluminum, 1 inch thick, was $400 from these guys. That's cheaper. That's cheaper than a vise.
Yep.
That's the other thing about this that you got to keep in mind too. If I got guys buying new machines, I got guys buying used machines, and then they go and they buy vices, right, to stick in there. If you buy 2 good Kurt vices, they're $600 a pop, let alone the cost of your soft jaws. Soft jaws, the cheapest soft jaws you can get. I forget the name of that website. I was going to have it pulled up, but I think the last time I looked at them, the set of 6-inch soft jaws were like $55. So, I mean, they're cheap, right? So that's pretty inexpensive, but you still have machining that you got to do on most of those soft jaws to hold on to stuff. Whereas if you get a plate like this, covers your entire table, costs less than 1 Kurt Weiss. Then you come over here to the types of clamping we're going to be looking at today, and we're going to start with the Pitbull clamping for this particular part. One of these little guys is 12 bucks, 10 bucks a piece. I mean, you can buy a lot of these little clamps for the cost of a set of soft jaws, let alone you don't have any machining time. So what we're going to do when it comes to this whole grid plate design stuff, I'm going to go into this program that I started this morning. All I've done on it so far is gone in and said, hey, I want the plate to be 40 by 20. That's all I've done. Then I went and added a, oops, wrong button. Then I went and added one drilled hole, just for the hell of it. So we can come over here and play this and see what it looks like. Because now we get to play with this a little bit. Look at it straight down. See our hole down here in the lower corner. So if we know what our part looks like, that's great. But at the end of the day, we don't care what the part looks like. The whole thing we're going to do here with this plate is we're going to make it a grid plate so that regardless of what part we throw in here, we can reuse this grid plate over and over again. So with that said, sorry, I thought I'd turn those notifications off.
Hey, Chad, can I ask you a quick question?
Yeah.
The software that you use, is this the standard software that comes with Herco machines?
Yeah.
Okay.
Yeah, this is what the Herco looks like. It's on every machine.
Gotcha. Great. Thank you.
I'm using the desktop version, which is the exact same thing that runs on the machine, but it every machine that I sell I give a seat of this with the machine. So.
Okay. Thank you.
Yep. So, and that's kind of a key point, Tim. And you'll get what I'm getting ready to say here about how I design fixture plates, and I do it in the machine, and why I do it in the machine. Because I can, dang it, because I can take my part programs and slap them on top of this grid plate that we're going to make, and make sure that everything fits right.
Excellent.
So, I've drilled a hole here. It's a 136 diameter hole, and that's for an 832 screw. And the reason I've done that for an 832 screw is because actually that's the smaller one of the two. That's actually the drilled hole for an 832 because it uses this particular Pitbull clamp that I want to use. You see this graphic here of how you have to design to use these. They have a knife edge. I like the ones anyway with knife edges. You can get them with blunt edge as it shows down at the bottom of your screen. But the one that I'm going to use is this this one right here, 26020. It's out of tool steel. It's got a knife edge on it. And this is the critical thing here that I'm circling with my mouse. D 100,000ths. Go back up here and look at this graphic right up here. That's all I'm going to be holding on to. It's 100,000ths of the part. And I'm going to be pushing the part up against a backstop. Okay. So let's talk about how I do this on the control here with the grid design. I'm going to go and make a new block. Drill. Most of you guys that are running the Hercos know what I'm doing here. And I'm going to go and select a list. Where's my 201? There we go. 201 drill for my quarter 20. Let's make sure that tool's set up right. Should have done this before. Sorry, guys. Yeah, 135. I get training classes a lot, and so sometimes people use my laptop, and then all of my drills and tools and everything get screwed up or erased or deleted, and so it's always fun.
Boy.
Yeah, it's always fun. So anyway, so there's my drilled hole for a quarter 20. That's the quarter 20 drilled and tapped hole that we're going to do is the grid that we want to go off of for how we're going to bolt anything else down, not your clamp, not that knife edge clamp, because again, that was a smaller one. That's an 832 bolt that we have to screw that guy into. But the 1/4 20, that's a size that I commonly use. You'll understand what I'm getting at here in a second. Oh, shoot. Drill, next hole operation, locations. And I'm going to do that one at 2x2. So there's my 1/4 20 hole right there. Okay. Now I'm leaving a gap right here on this side. Because again, if you let's say you bought that plate from Howard and it comes in, great. It's a perfectly ground plate. You don't have to face it. You don't have to do anything, but you still have to hold it down some way. So you slap that thing on the table, you clamp it down somewhere with, you know, some normal T-bolts and what are those kits called? The tie down kits anyway. So you bolt it down to start with. And then in these, what I like to do is in these corners right here on the sides, as well as 2 inches in over here on the side, is just drill and counterbore some holes for some socketed cap screws to go right through the T-nuts anyway, through your grooves on your table. So you have to space those out for whatever your T-nut locations and grooves are on your table. But then you're bolting it down probably 3 times this side, 3 times this side, maybe one in the middle to keep it from bowing or anything else. But a total of 8 socketed cap screws holding it down is good enough. Leave the rest of it open. If you want to get fancy and you want to make this thing where the holes are all the way through so coolant can drain and all those kinds of things, then of course when you're doing this part of it, you just put some spacers underneath it. And then when you're done, you can bolt it back down. But for now, we're just going to talk about the grid size. So anyway, I got my 1/4 20 down here in the lower left-hand corner. That's my one hole. How many do I need? I'm going to insert a pattern, loop rectangular. I have no idea how many I'm going to need over that 20 inches or what my spacing is going to be. Or that's 40 inches across in X and less than 20 anyway in Y. I have no idea. So we're just going to do maybe 20 in X and 10 in Y. And we'll do our spacing. Usually I do my spacing at a 1/2 inch each to start off with to kind of see what that looks like. And we can play around with it once we get it in there. Yeah. And it's going to be a lot of holes. It's a lot of drilled and tapped holes. So obviously we can do quite a bit more than just the 20 by 10. Each one of these drilled and tapped hole locations is going to represent how I position my part, okay? So if I think about throwing that block in on top of this grid, we know that we've got that, whether it's that Pitbull clamp or one of these other knife edge clamps that Mighty Bite has that we're going to go back and look at here in a minute as far as putting them in on this table somewhere. If this first hole down here was one of my pit bulls, we've got to mill a groove or a slot along this in order for that to sit down in. All of these drilled and tapped locations can be where my part fits. All right. And then on one of the ones in the back is where we would have our stop, which is that same stop. If you go back and look at this view right here, there's your stop that would be bolted down into one of those 1/4 20s. Here's our block. And then where that first hole is, where we're going to put our groove, is where the pit bulls would go. Does that make sense to everybody?
Yeah, it does to me. Yep.
Okay.
And if I can just add a quick note, this is Tim from Mighty Bite. We do have locating rails that do have 1/4 20 fasteners. They're a stock item that can be bolted theoretically to that grid pattern too. So.
Right. Yeah, so there's a clean and neat way to do it where you're buying those. There's also the quick and dirty way that I usually do when I'm actually doing one of these fixture plates at a customer's as part of their training when they buy a machine. And we just go and grab aluminum scrap off the floor somewhere and drill a couple of holes in it, and there you go.
Absolutely. Yep.
Yeah, I mean, it's whatever you want to do. I usually choose 1/4 20. That's a common size. Everybody's got a 1/4 20 tap sitting around somewhere, a 201 drill. Plus, it's a small enough size to be able to give you these nice, big, hefty grids like this. So without really doing a whole lot of thought, we've just thrown it in here. We've gridded it. How much distance do we have here? We can just sit here and measure this and say, okay, we've got about 10 inches right there. So that's good. When I said I had that 10-inch, if I was just going to do a 10-inch bar of brass and I can throw this guy in here, let's do that. Let's see what that looks like now. So I can come back to my other program. I can highlight everything, copy that, go back into this guy. And I'm going to come down here at the end and paste it. Okay. So there's my whole block program. I'm going to go view this from the top, and I'm going to, just to make this look a little faster here, we're just going to do toolpaths only. So we can see what this guy looks like on the grid. And we can move him around a little bit too. No, I don't think I put in, let's see, toolpaths and part surface. There we go. So we're going to see our first grid. I guess I can speed this up. I'm trying not to tax my system too much because we've got a lot going on, plus the whole video sharing and the recording of it as well. So there's that block, right, that we laid out, and there's our grid. So if we wanted to look at that in terms of spacing now, we could say, okay, well, from where my 0, 0 is here up to somewhere up here, it's, you know, it's probably like 2¼ inches up and 2 inches over. So we can go throw a pattern around that real quick, just so we can all be on the same page of what we're looking at. Patterns, we're gonna do a location, and I'm gonna move it 2½ inches up by 2½ inches up just to make it smooth. I'll just make, oh, that's right. When you're doing patterns, you have to turn tool optimization off. Anyway, so we'll be able to see, okay, that's how that thing is slapped onto our grid, right? So obviously this would have to be a little bit closer, but we could tell by when we're doing this if this spacing is going to work for us for this particular part and where it would need to be. It'd need to be moved up a little bit closer. I think that Pitbull, this might even need to be moved up a little bit closer in order for this Pitbull to be able to hit as it's sticking out here. But that's okay. We can just take this guy and move it up. And now we know that then we would know that this first location of drilled and tapped holes is good if this is lined up to it. And then right through here, maybe on grid number 3, where our stop needs to be able to process all of these, right? Is that making sense to everybody?
Yes.
Okay. So let's go back and let's look at what it takes to actually machine this groove in for this Pitbull. So we make sure that this spacing for where these holes are at and where this is right, so we can actually hit something, right? We would need to be able to clamp on something. So according to this drawing right here, we're going to have a C width for this tool we're wanting to use. This guy right here, he's got to be a 1/2 inch. So we've got to cut a 1/2 inch end mill. We're just going to use a 1/2 inch end mill anyway, slot across the top of that plate, and then make sure our spacing here, A, for that drilled and tapped hole is 200 thousandths off the top of it. Huh, weird. Okay. I got a weird little error mess. Anyway, so that's what we're going to have to do. So we'll come back over here. We'll come up to the top. Somewhere, insert, milling, lines, arcs. You guys all know how to do this. All you Herco guys know how to do this part, I would hope. How deep is that, by the way? I didn't even, well, I've got
200,000. I think it's 187.
187? Okay.
I believe it is. Yep.
Good enough for now. Oops, that's not where I wanted it. Put that at 0, 0. We'll do 187. And then in terms of our X and Y start, where were we at? We were right there. 160, 160. Okay. Two and one. Okay. Oops. So we were up 2 in X, and we needed to be yeah, 200,000 up off of it in terms of Y, and that was at 1, so 1.2. Actually, I'm going to start that at 0. Next line. Give me a line that's 40 inches long at 0. There we go. So now we've got our groove. There's our groove. There's where our hole is. Oh, I guess I'm going the wrong way, aren't I? Don't ever do this. I'm doing something wrong right now. I just said right. Yeah, I know it's wrong. Whatever. Should have started from the other side, gone this way. But that's okay. There we go. Now you can see where our edge is, where it needs to be, and there's where our hole is. That's in the right spot for our hole. If we needed to move all of this up in order to clamp on something, which we clearly do, actually what we'd probably do is just move this grid down. And in this case, actually, what I would probably do for a part like this is I'm going to wind up having multiple grooves, and I'm going to space them out, and then I'm going to give about as much room in here as what I think my common parts need to be, okay? So if I said that from this edge up to, say, somewhere in here, that's 2.8 inches. This is where not everybody's fixture plate is going to be identical, okay? It's always going to be a little bit different. And not every fixture plate you do is going to be a 100% fit for every part you run, okay? I'll get to that in a second as to why this is still the way you want to start, something like this. If you're doing a lot of parts like this where you want to hold on to a small amount at the bottom to be able to flip it over and face it off, which is what we're going to do in this example, then you want to use these Pitbulls. It's the easiest way to start with. There's other options there. Tim can get into that here in a minute if he wants, but from my point of view, this is the easiest way to get started. You're cutting a groove, a couple of grooves to give you indications and spacing. We're going to move these guys down and then try to space them out to where we get about 3 inches worth of space here. And what that's going to give you is if you got a 1 inch wide parts, well, they're going to take up this area in here. You have 2 inch wide parts, they're going to still be able to go back here. And the stop that bolts down into where all these holes are is just going to move in and out away from or towards your Pitbull clamp. Is that making sense to everybody? Yeah, no, maybe?
Yes,
okay.
It is to me. Yep.
Andrew, what about you, buddy? Is that making sense to you?
Yeah, it's making sense. Sorry, I'm just getting ready.
That's okay, man.
Woke up a little late.
I see the guys from Profile are on. I don't know what your name is, but does that make sense to you?
Yeah. I had one question, though.
Sure.
Are those bites pretty expensive? What do those usually run?
The Pitbull clamps are cheap. Tim, you could probably answer that better than I can, but the last time I looked at one of those Pitbull clamps, they're like $12 a piece.
Yeah, which part number was that, the 832?
It is this one right here, 26020.
26020. There's 8 pieces in a pack, and they're $79 a pack, so like $10 a pop.
Yeah.
Bad.
No, I mean this whole solution here, Andrew. You missed this first part when I was talking earlier, but this whole solution here of how you go about doing this, not only is it more efficient for your parts in terms of setup, cycle time, it's cheaper to do than going and buying 2 Kurt Weisses and soft jaws.
Yeah. No, so, you can put way more on a plate.
Yeah. So let's go back and look at that plate, by the way, these holes here. We don't want to do 20 by 10 anymore. We've already figured out we probably only need 5, right? And maybe we want to do, 40 or something like that. We're going to have to move that spacing down. That looks a little bit better in terms of what we're trying to do. If we have a back rail here, this is obviously going to have to move down too. I should have probably looked at these numbers a little better and had actual numbers, but I like doing things on the fly if you haven't been able to tell. Let's just take this first location here for this first drilled hole and take its Y down to like 1.5. Let's see, it's 1.2. So yeah, 1.5. Let's see what that does. Wake up, come on. That's better. That's better. You want those right up next to it. That way you get the best spacing here for wherever you're going to hold down on the back row, your piece that you're holding down. So all this can obviously move right up to the edge. And then, of course, we could extend that out. But the whole point of this then is to be able to say, okay, well, we've got this whole thing done here. We could take right in front of this, insert another pattern locations, and say, okay, leave the first one where it is. Let's take the second one, offset it up in Y. Let's see, we have 20 inches divided by 20 divided by 3, 6 inches. Let's try to do like 5.5. And then another equal spacing there. No, we have more than that. Probably going to put this in the wrong spot. See if this gives us an error or not. There's our 3. So we could probably condense this a little bit, maybe even get a 4th row in there. You don't want all this space here. I probably left way too much room in there. Let's check that real quick. If I go from here up to here, yeah, 3.5 inches. So we can definitely get 4, because even that up to there's your 20. So yeah, we can get 4, maybe even 5. Okay.
Dang.
So we can condense this puppy down, and now we're talking about getting a ton of these on there. And again, when I was talking earlier about instead of cutting all these individual brass pieces up, you're just cutting a strip, and that strip's going to be however long this whole plate is here. And so you might only need, would you say they came in, Tim, a package of 8?
Yeah, a pack of 8. Yep.
So a pack of 8 right there, a pack of 8 right there, and a pack of 8 right there, just on the 3 would hold down your 3 bars that could be 37 inches long.
Yeah, on like a 10-inch piece, you probably have, a clamp on each end, about a 1/2 inch end, and you'd have 2 additional ones equally spaced. So a pack, you could clamp 2 bars 10 inches long.
Yeah.
I think each clamp is generating 1,500 pounds of force multiplied by 4. So that's almost the equivalent of a 6-inch vise as far as holding force goes.
Right. And doing some quick mental math here, if I just have my bar be this whole length, right, 37 inches, because of how wide one of these pieces are for clearance and everything, I can get 23 of them. 23 there, 23 there, 23 there. If I did a 4th one, I'd have 4, and I can fit 4. So it's 23 times 4. Now I've got 92 parts on the table, and I only had to handle 4 bars to do it.
Yeah,
that sounds a hell of a lot easier than trying to handle 2,500 individual little chunks of brass coming off your saw. So, or however else you wanted to do it. Even if you're just cutting them in lengths to do 4, right? And you just put them into your vise, and you've got 4 of them coming off instead of having them individually be cut. That's still a lot of handling.
Basically parting it off with like an 1/8 inch end mill or something as you go.
No, I leave this whole thing complete. When this is what I would do with this. That whole bar goes on here for op 1, okay? And you do all this machining. You've still got op 2, but you're only handling a bar.
True, because they're not parted off yet.
They're not parted off yet. So when you flip them over, guess what? That's where this little channel you've got cut becomes a nice little handy deal here. In this particular part, you couldn't shove it down inside that because it's too tall. If we go back and look at the individual part, guys, where you can see the part a little bit better.
Yeah, I don't know if I've caught this yet.
Yeah, you haven't seen this part yet. Here's our individual part. That's the 10-inch bar.
Mm-hmm.
It's going to wake up here and go. There's 4 of them anyway, cutting the individual bar so you can see them.
Okay, so yeah.
That's your little part. That groove we're cutting for the Pitbull clamps isn't deep enough for this right here. That's a 1/2 inch, right? So it's not deep enough to be able to put that in there and then clamp something up against that from the outside and face this off. So that sucks, but that's okay. In some cases, that groove becomes a perfect spot to be able to flip something over and do that. But when it doesn't, for little parts anyway, like this, that's okay. We can still flip this whole thing around on the bottom side. Oh, come on, wake up. Right? When we flip this whole bar over, we're going to have a bar in our hand that looks like that all the way up and down.
Yep.
So we can still put them down. And that's where the one thing I didn't do that I forgot about until right now when I'm looking at it. When you machine these, you probably wouldn't want to machine them where they're going this way on that bar. You'd want each of these parts rotated 90 degrees. That way this whole edge right here is running the length of the bar, and you could put a spacer underneath it.
True.
That way you can put a spacer on it, clamp it down that's where we go to these different types of clamps here that we're going to look at, because there's all kinds of clamps that we can use. We'll go back to products page on Mighty Bite. We'll come down here and we'll look at these knife edge clamps. And so if you think about a piece of scrap aluminum or scrap steel that's sitting around, you can put it up onto this grid plate to use as part of your spacer. Maybe you have to go and run an end mill across it real quick to make a flat surface or do something like that. Drill a hole in it real fast. Hold it down with a socket cap screw, 1/4-20 socket cap screw. And now on the outside of your brass part, you use these knife edge pieces to clamp that against it, and off you go. And all you're doing is facing the backside off, and you're finished. And they just fall down. Or actually, they're going to be held in place, so they're not going to move. But you're just cutting all that excess off on the backside. So your cycle time to go your 40 inches in X across it is nothing. It's a second or two per part, because you got 92 parts on the table, and all you did is move from 0 to 40 inches in X 4 times.
Yeah, you're gonna buzz off that carrier material. This is Tim Crafton with Mighty Bite. It makes perfect sense, Chad. You're gonna flip it over, hold it with a clamp, buzz off that carrier stock, and you're gonna have parts that are done.
Yeah.
We call that the carrier method.
Yep.
Here at Mighty Bite, but it's certainly a common thing that people do, and it's using the bar idea. It's really slick. It works out great.
So we're just going to pretend that those parts are rotated 90 degrees, because I should have done that. Sorry. We'll go back to this, and let's analyze some cycle. I can't analyze the cycle times until I go and take it all out and do it as a bar. I got to take the whole grid out, because then I got to put Tool Optimize back in there. Without Tool Optimize, it'll really suck. But you get the picture.
Yeah. What's your opinion on those pneumatic, fixture plate holders? They have like a snap ring that you can press the trigger down and pop off the plate and set another plate on there.
Yeah, so that gets to the next thing. That's a good point to bring up. Let me finish with this thing real quick, Andrew, and then I'll answer that question. Because there's a lot of fixture plate stuff that I've designed so far where we're using with the one that we used anyway, the main one that we used was a Jorgen's ball lock, to where you could just quickly take another plate on and off of this plate. Okay. Yeah. And that gets into, let's talk about just this quick design that we did together here real fast, for no time at all. May or may not be the perfect design for every single kind of part you're going to do. Because again, whatever this spacing is from here to here that you come up with, that's going to be the biggest part that you can use with these bull clamps, right? So let's say, like right now from here to here is 5 inches. That's about 5 inches. That's not bad. I mean, if you got a 5-inch part, you can still stick it in here and clamp that sucker up and go. And you can put them in a grid and have, you know, a 5-inch part that's 8 3/4 wide, and you could do it 1, 2, 3, 4, 5, 6, 7, at least 9 times, maybe 12 times. You got 12 parts on there as opposed to 2 with 2 vices, right?
Yeah.
So your changeover time gets cut down, all that. But if we were to put a different part in here, you know, would it still work? Would it still fit? Well, I don't know about you guys, but I would say for your smaller stuff, I can't see how anything wouldn't fit in here, even if it's just a onesie twosie thing. And with those knife edge clamps that I was showing you on the other screen, these guys right here, look at how they're doing these in this view, right? They just got, and you can get them where they're 1/4 20. Where's it? Shoot, 3/8. I thought those are the 1/4 20s.
Yeah, we do have some camp style that are 1/4 20s.
Okay, and those are on the other. I think those are the not the knife edge ones, but they're these.
Yeah, the original
fixture clamps. Yeah, these guys, where they're still cammed, but they're 1/4 20s, right? Right there. So now every single one of these 1/4 20 holes. Come on, wake up. Becomes a place that you can use to clamp something down. So let's say you do get one big old part, right? And this fixture plate's in your way. It's actually not in your way. Slap that part down on the table anywhere you want it, anywhere, and use these to push up against it and anywhere it's sitting. I don't know if there's a really good photo of that on here of something big where it makes sense. I don't see a lot of grid plates on some of these examples you've got in here, Tim, but
that one down there towards the bottom. Just go back down real quick.
yeah.
That one, the third from the right, second row. Next one over to the right.
No, there's a big part that was slapped in there, and you can see 1, 2, 3, 4. There's probably around the backside where they just bolted it up where it could fit.
Go to the picture to the right.
Okay, I'm right here on this round one. Am I going to the right?
Yep, that one right there.
That one right there, yeah.
Yeah, that's kind of like what we're talking about, basically, right?
That's basically what we're talking about. But they've got these recessed, so they're not holding on to a lot of the part. You can do that too, but you don't need to. There's the stops that they've got put in there. We've got a lot more of them on our table for what we've done so far, right?
It's like a smaller scale, yeah.
Yeah, but I mean, if your part was, you know, let me see if I can get this to draw. Wake up, trying to draw. Oh. So say your part's this big, right?
Mm-hmm.
Well, would that fit to where you could clamp here and clamp there, and we'd have these holes keep going out, clamp it right there, right? It'd still fit.
Yeah.
So you've got the ability to be able to do large stuff as well as your small stuff. Now, let's say you wind up doing something that's not going to work, right? Just for whatever reason, it's just not going to work with this grid plate. Well, again, the reason we want to leave a little bit of space on this side as well as the other is so that we can go back and put things like a Juergens ball lock system on here, to where now we can have a plate that snaps right on top of this with a half a turn of a handle and put our own grid if we need to on a smaller piece of material, right? And that gets to what I call the trays method, to where maybe on this half, you've got a different grid for your specific part that's taking up this section here. Why is this wanting to come up and go away? That's taking up this section here, and it's running while you take this tray off and it's on the table, and you're taking the parts off, putting new parts on, and then it comes in and then it's running this side while you're taking this one out. And that way the machine's constantly running while you're swapping your parts in and out off the table. If you're not doing something in a long bar, or you do have to put a whole bunch of parts on the table and take a whole bunch of parts off the table every time you open and shut the door, that's the next step where you might want to think about putting a subplate on top of this main fixture plate. And another thing that most of our guys, I have them do, just so that the terminology from one setup to the next becomes a little simpler over time, is I go and engrave all of these each row becomes A, B, C, D, E, right? And then maybe this is A1, A2, that kind of thing.
Yep.
That way in your setup sheets and in your part process and all of that, you kind of have an idea of where this thing is supposed to be slapped. If you need to do that. That's big in the aerospace industry for different parts. Not so much anywhere else, but I see people using that more and more outside of it because it just makes sense. You know, where the program's coming off of, it's coming off of A1, or it's coming off of, you know, some guys just have all their letters going across the top and their numbers going all across the side. And now you know exactly where in the grid your 0 is located off. And if, in case you're doing all this stuff from CAM, most of my guys I have, we're doing all this in conversational, which is what you've seen today. But if you've got stuff coming out of CAM and someone's dumping you a huge G-code program, it's kind of nice to know where the 0 is coming from right off the bat without having to try to figure it out.
Yeah.
So,
or having somebody follow up after you and trying to explain your setup.
yeah, exactly. So, okay, we've gone through a lot. We've gone through 50 minutes already. I can't believe it's gone by that fast. So that was quick. There's a lot more that I could go over. I mean, I could be doing this for probably another hour or two. Tim, is there anything specific you think you want to point out with this type of what we've been talking about here today that maybe you think I should have covered that I didn't?
No, I like what you did. Just, I don't know who else is new to this since we started, but my name is Tim Crafton, Senior Sales Engineer with Mighty Bite. And you know, what Chad's showing is certainly a great example as far as the carrier method, using the grid pattern, having the Pitbull clamps fixed at one point and allowing the hard stop that he was talking about to grow, you know, back and forth as the parts changed. Makes good sense. You know, having a bar on there, a solid flat bar, machining parts out of it, you know, for the op1 scenario, flipping it over. We have a bunch of different clamps that could be used, the knife edge clamp, the original fixture clamp that he's showing now, you know, Uniforce clamps. ID expansion clamps are nice. If you have parts with holes, you can flip them over and up too, drop them on, you know, expansion pins. You can locate that way and hold on the ID. This way you can machine the full perimeter and separate each piece. And it's a good method as well. But no, Chad, I like what you're doing. The grid pattern setup certainly makes sense. It sounds like, you know, Howard Precision, you know, has some really good pricing on that ground plate, which is nice as well. So, no, thank you. Excellent job.
All right, guys, anybody else have any questions or any comments back and forth?
I have one question.
Sure.
For like round stock material, is there a picture, like an example on there, how, like what kind of clamp you would use for clamping like round stock?
Sure.
Same ones. I mean, it's really the same. It's really the same thing. Like I was showing over here on the screen. You know, if this was your round part right here.
Oh, I mean, like if you want
to what would you use to clamp it with?
Like if you wanted to clamp a bunch of small, like 1-inch diameter stuff.
Oh yeah, sure. Same, the same kind of stuff. Tim, if I'll look up a picture here while you're talking.
Sure. Yeah. Let's go to products. We can take this offline as well. It's no problem. You know.
Mm-hmm.
But let's go to products real quick, Chad. You're there. Yeah, let's scroll down. The most common clamp, we have a few different options, but if you look for the machinable Pitbull, machinable Uniforce clamps, which is going to be under that yellow fixture clamp header, we're going to look under that. Correct. Yep. Click on that picture. So with this clamp here, the Uniforce clamp, I'll just wait till that loads.
Yeah, I'm not sure why it's not.
But the idea is,
Yep, like that.
Yeah, that picture right there kind of really highlights it.
Oh, okay.
Notice how that's up off the ground too.
Yeah, I mean, you can set it up if you have through holes. You can mount it right, you know, on the top of the fixture plate. But the idea is we have different sizes. And what you do is you machine that feature right into the clamp. So you drop them in these little pockets. And you can machine away depending on what you're doing. You know, for those of you who have, you know, application questions as far as work holding goes, you can certainly reach me at tim@mightybite.com. And no, I'll be sure to be glad to help you out with some thoughts. We have like you're seeing on the website, tons of application pictures. We
Yeah.
have tons of CAD models of stuff, things that are already created in SolidWorks that allows you to look at it and say, oh yeah, I'd use this clamp, so we can certainly help you out that way.
Yeah, all of these different ones we've looked at, they have this little link right here for CAD, and you can literally download that, bring it into your system. Some of those I was looking at have DXFs, which means guess what? You can bring it right into the Herco control and see it and now you can see where your clamp is on the screen and position clamps around and see if your design is going to do what it's going to do. You can do it all right in the Herco control using their DXF CADs anyway, or DXF, bring it into DXF. So that's kind of slick. Kind of like that, and of course with this here, this gets you this, like we were saying, you can see in this top one here, it maybe doesn't make sense, but when they machined that diameter, they left a ledge down there. So now the whole thing's up off the ground. It's all, you got clearance there, and you can do that on all these different various machinable these machinable clamps that they've got. They've got a whole ton of different ones. There's all different sizes of them too. And there's even machinable ones that are rails like this, long length machinable. All of these can be bolted down in that grid plate anywhere you wanted, and have all of these to where they're sticking up. And when these things clamp down, let's see if I can get this to pull up. When these things clamp down, they're clamping both ways, both up and Y and down and Y as well. So one clamp is actually pushing against two parts. Like it shows right there.
Yeah, that's right.
There's no pictures on this one, I don't think, but I mean that's a pretty common one to use. Now, granted, that's once you've machined that and done these little grooves, well, it's for that part, which is why you'd really want to think about that. If you're going to do it for round parts and think about how you're doing it, then maybe it's a 1 inch diameter, 1/2 inch radius, and that could be used. Maybe you make it a little bit larger than that, so it could be used for a 1/2 inch, or it could be used for something that's 9/16 or 7/16 if you have a lot of parts that go into that range.
Yeah, a lot of guys will, this is Tim from Mighty Byte, a lot of guys will put V's in the face of the clamps. This way you're not limited to the radius. You can grow whatever diameter within reason by having a V notch in the face of the clamp.
Oh, that's a good idea. A bunch of like V blocks essentially.
Yeah, exactly.
Yeah.
So you can go to a small size or ramp it up depending on which one you have. Yep.
I used to use these. I had a little job back when I had my shop, a 3/16 diameter piece of material. It was a stainless material. I don't know what this, I can't remember what the material was. This is back in like 2010, 2009. But I had to cut an 1/8 inch groove all across the length of it. And they were 12-inch long parts that were 3/16 in diameter.
Yikes.
Yeah. And so the only way to hold on to those was in between two V notches, basically, in one of these things, basically on a plate.
Yeah.
And let it sit in there. Then it couldn't move. It couldn't go anywhere. So
clever idea. Yep.
Yeah. Any other questions, guys?
Not really. It just, that's pretty much everything. Yeah, I've kind of looked into those pneumatic fixture plate holders and.
Yeah, when you get into that stuff, now you got plumbing. I mean, it can be partly automated and all of that. One of the future advanced classes we're going to be doing is going to be talking about automation and how you can get a fixture plate or even a non-fixture plate set up to work with automation, to where you've got on the Herco side, you've got something called job list, which allows you to say, okay, I want to run programs 1 and then run program 2, then run program 3 and then run program 4, and how that would work for you in a fixture plate style setup, whether you're using everything on just one plate like this, or you've got sub plates that are in there as well.
Okay.
We'll get into a little bit more of that. Now, getting into the pneumatic stuff and all of that, that's hard to do like this in a webinar, because you get into plumbing issues and all kinds of stuff. But
if you had that kind of setup with a fixture plate with that many parts like we were talking about,
yep,
that would, where you just, while that one's running in the machine, you have the other one taken out, you could actually change the parts. That would be crazy.
Yeah, it'd be nice.
Yeah. No, those, I'm going to have to look into the Mighty Bytes. I don't know. I probably have to buy them myself, but.
Yeah, you guys don't have any there, Tri-V.
No, but. No, those, they do look like, I mean, I've never even seen them before until like a month ago, and I wish we did have them.
Well, we can get into that later with you, help you out any way you need, talk with John and those guys and see what we can do for you. So
Yeah, they're not that bad. I didn't know how much they cost really. So,
no, they're pretty inexpensive.
yeah, no, I'll be in touch with them for sure.
All right.
So,
Anybody else? I think we should probably wind this thing down if there's not any other questions.
that's it for me.
Nope, one more question.
All right, guys. Well, you know how to get a hold of me. See Waldo at gagemachinetool.com. You can text me at 913-982-7851, or you can get on our website. There's lots of ways to get a hold of us. I know some of you guys are from the Instagram channel, Gage Machine Tool. So reach out to me any way you can. I'd be happy to help. Any ideas, thoughts, or takeaways from this? Training is one of the things that we do all the time at Gage Machine Tool. So thanks for joining. I appreciate it.
And Chad, and thanks for inviting us, Mighty Bike, to be part of this as well.
Yeah, Tim, you guys have great products. That's why I wanted to bring you in. So I appreciate your time.
Yep, and any way we can support you or the participants here, just reach out to us. So thank you very much.
All right. Thanks, Tim. Thanks, everyone, for joining. Appreciate it.
Yep. Thank you.
Thank you.
Thanks, Chad.
Thanks, Chad.
Thanks, guys.